Here we go. So today's date is November 1st. First day of November. October went by pretty quick. All right.
October went very fast. I hope this goes very fast too.
It's almost my birthday. It's in 2 weeks. November 14th.
All right. So we're going to be simplifying expressions. Now, kind of like Thursday when we did distributive property, the simplifying expressions, your answers look like problems. Okay, Jesus, your answers look like problems, but you are technically done, even though they look like you can still do more stuff to it. You can't. So, for example, I have 2x plus 4 plus 3x plus 9. Okay?
2 plus 3, 9 equals 5, 5 plus 4 equals 9, 9 plus 9 equals 18.
What?
You were correct halfway through, and then at the end, no.
Oh wait, never mind. 5x and 13.
Yep. All right.
I messed up.
Yes. So, you know how last week I had you circle the terms, and terms were separated by addition and subtraction signs? Well, that's going to come into play here. Okay? So we have here 4 terms. We have a 2x, a 4, a 3x, and a 9. And to simplify expressions is we're going to what is called combine like terms. Combine like terms means combine what is similar to each other, what is alike. Okay? So if you had, 2 Kit Kats, 5 M&M bags, another Kit Kat over here, and Reese's Pieces, you would put, like, let's say all the Kit Kat together and say, like, oh, look, I got 4 Kit Kat bars, 2 M&M bags, and a Reese's Pieces. You would rearrange your candy to see, like, okay, well, how many Kit Kats do I have? How many of this do I have? So it's combining like terms, which I do have. I can do that. I can do that example with the real candy. So, combine like terms. So, everything that has the same variable can be put together. So here I have a 2x and a 3x. They both have x's, so we're going to put them together. We're going to go 2x plus 3x is equal to 5x. And then the numbers that don't have any variables to them, like the 4 and the 9, they go together separately. 4 plus 9? 13. So we put the ones that look alike together. The ones that have x's together, the one that have nothing together. Just numbers. And our final answer would be 5x plus 13, and you're done. So it's very kind of like what we did on Thursday with the distributive property, but one step further. A lot of kids want to put these two things together, but I'm like, wait, the 13 doesn't have an x on it, so you can't.
That's where I messed up.
Yeah, but it's fine. We're trying. All right, let's do
5c plus 3c minus x plus 9.
5c, what?
Plus 1,977.
3x minus 5x.
Sorry, 5c plus 3c?
3c
Uh-huh.
minus 2c plus 1x.
All right.
That just came to my brain straight up. I don't know why.
And you know what? We can do it. So we have 5c, 3c, and minus 2c. I'm going to circle the minus 2c. And then we just have a 1x. I'm going to box that one. I'm going to change the shape. Why am I going to change the shape? Because this one's an x, and it's different than a c. So if I line up all your c's, I have 5c plus 3c minus 2c. Okay, what's 5c plus 3c minus 2c?
5c plus 6c.
This gives you 8c. Minus 2c gives you 8c. Is there anything I can do with the 1x. I wasn't finished, okay? I wasn't. This is just like it's like an extra decoration on the 6. Like a hat.
Oh, that kind of looks like an 8.
But it's not. Because Miss Lamelli knows how to do math and she knows that's a 6.
He forgot to take off his costume.
Yeah. He slept with this costume on. Alright. So, our final answer is 6c plus 1x. In algebra, if you have more than one variable, you put in alphabetical order. Okay? In algebra, see the 1c? the 1x? Your final answer would actually be written as 6c plus
Wait, is that 8 or
x. That's a 6.
we had a whole entire conversation?
Excuse me? Well, this is an x and this is a 6c. This is like 6 candy bars plus an x-ray. You can't say you have 7 candy bars. No, you have 6 candy bars plus an x-ray. Because you randomly took an x-ray.
But what if the answer was 6c plus 2x, but it still be x? Come on.
So, this brings me
Change it to x.
This brings me to this point. In algebra, we do not write the 1x. There is an invisible 1 here that 99% of the time you will not see. It will be written just as x, but it has a value of 1x. We just don't write the 1.
So what if it was a 2?
You will see every other number other than the 1. If it's 2, if it's 5, if it's -3, you'll see it. The only number that disappears is a 1. 1 will disappear. It still has a value of 1. There's an invisible 1 here.
The x counts as a 1.
Yeah. So if you just see a variable by itself, it is actually equal to 1x, 1c, 1h, whatever. Doesn't matter. All right, so let's see. So let's do that. 5x plus 3m plus x plus m plus m. 5x plus 3m plus x plus m plus m. Yeah, m and m's.
Okay, that equals 6x plus 5. Oh wait, I messed up.
Pluses, I don't use the variable t.
5m plus 6x.
Okay, me done.
What did we say?
Answer is 5m plus 6x.
Thank you for putting it in order. All right, so the x's go together, and you have 5x plus x. Now sometimes kids, oh, that's 5x, Miss O'Malley. I'm like, but what's invisible there that we don't see, but you know it's there? The 1. So then we go, oh, that's 6x. And then we're going to put the m's together. And we have 3m plus an m plus another m is equal to
5m.
5m. Because there's an invisible 1 here, and there's another invisible 1 here. In algebra, we don't write them. We just know that they're there. We know that they're there, but we just don't write them. Now, our final answer is 5m plus 6x. Why did I put the m first? Alphabetical order. Alphabetical order. Are we okay? It looks hard. 100%, you're like, oh my god, there's a lot of variables out here, like what? But when you start really doing these over and over, you realize it's honestly like second grade math. It's like, what's 5 plus 1? 6. What's 3 plus 1 plus 1? 5. It's really, really easy. It just looks very hard and intimidating. And your answers don't look like they're done. You feel like, hey, I can do more, but you really can't. You're really done. Are we okay?
Yeah, it is.
Let me see. Let me give you a hard one.
Oh, a hard one. How fun. Something to do.
Oh, this is not hard. It's not hard.
Is it a G or a Y?
It's a Y.
Okay, let's see.
Cobot, Jesus, write it down.
What was that?
I don't know what Brianna's doing back there. Silence? Silence it.
Island Adventure.
Silence it. Alright, what do we guys get?
I got 5y plus negative 4x.
Yep.
That's the answer?
Yep.
Oh, wow.
Yes and no. 8y minus 3y. So be careful, it is a minus. That gives you 5y. Okay? So if there's a minus, make sure you subtract. Then you have 6x plus negative 10x, right? So you realize what we learned in the beginning of like October, I think.
Would be 4x.
So the signs are different, so you subtract. Do you have more negatives or do you have more positives?
Negative.
Negative 4x, right? So our answer is
5y.
XYZ. XYZ. So x came first, right?
Oh, well,
Negative 4x plus 5y. The reason in algebra we put it in alphabetical order is so at the end all our answers match. Because if I go like, oh, it doesn't matter, you can put the y in the front, you can put the x in the back, then our answers would still have the same value, but we would be saying them differently, and sometimes a student might get confused. So if you put it in alphabetical order, when we all say okay, everybody, what's our answer? Everybody says negative 4x plus 5y. Yay! Yay, we did it. Any questions? Are we okay? All right. Let's try some class work.